In today's video, I will be finishing the second half of the 5-4 notes. Today, we are just going to discuss simplifying radicals. So, we already took the perfect squares notes back in the day 1 section of 5-4. So, I just copied and pasted my list onto this page. It's going to definitely come in handy in just a moment. So, example 1. The square root of 49a to the 8th power. When you simplify a radical, you want to break it down. So my first piece of advice is to rewrite this completely split up. So let's rewrite this as the square root of 49 times the square root of a to the 8th. This way we can look at each part separately. Now for our 49, we have the ideal case here. We have a perfect square. So I know this is going to give me a 7. And then I'm going to figure out what this gives me, and then I'll be done. Over on the right side, I'm going to write out the steps as well. So step 1 is what I just did. Write the number using perfect squares. All right, our next step is going to explain how to deal with variables. Variables. Divide the exponent. Let me say this differently. Put into exponent form and simplify. That's a better way to put it. So to demonstrate the point real quick, I'm going to do 2 quick examples just to show you where we're going with this. So if I had the square root of a squared, remember, the square root has this implied 2 in there. And then if I rewrote this in exponent form, remember your base is a, and then your exponent is a fraction. And remember that fraction relationship is in over out. Inside number over outside number, 2 over 2. This gives me a to the first, or just a. So I can rewrite the square root of a squared as just a. I'll do one more. The square root of a to the 4th. Again, a square root means there's a 2 here. First, I'll rewrite it as just an exponent. So a, this will be a fraction. Remember, it's in over out. Inside is 4, outside is 2. 4 over 2. And then 4 over 2 is just 2. So this is the same thing as a squared. So I'm trying to figure out what this would give me. So for our example, I'm trying to figure out where I want to write my work at. I'll write it here. Remember, this is a square root, so we have an implied 2 here. Rewriting this as an exponent, we have a, and then we have a fraction, and then it's in over out, inside over outside, 8 over 2. So then that's going to give us a to the 4th. And I'll just bring that 7 down. So putting this all together, my final answer is 7a to the 4th. When you multiply, you just smush them back together. So So that's really going into detail and breaking down the problem. Obviously, if you want to show this much work, that's fine. But this is just me really digging in and showing you where all of this comes from. Next problem. Again, I've just copied and pasted my perfect squares list. You don't have to write this down every time, but it's helpful to have this insight when you're doing the problems. Number 2, the square root of 48, x squared, y to the 4th, z to the 12th. So again, I'm going to break this apart into its individual pieces. So I have the square root of 48, square root of x squared, square root of y to the 4th, and the square root of z to the 12th. All right, let's tackle the number first. Now, 48 is not a perfect square we see on our list. It's not in there. So what you want to do is find the largest perfect square that you can divide 48 by. So obviously we're going to start with 36 because 49 is too large. And I'm going to go down the list till I find the one that does divide into 48. So, yeah. I always manage to do that. Okay, this takes me a second to do. There we go. So I'll demonstrate this one good time. So, 48. I'll start with 36. Notice that's an ugly decimal. I want a whole number. So I can't divide it by 36. Our next number down is 25. Still a decimal. All right, let's keep going down. 16. If I divide 48 by 16, I get a 3. So this is the largest perfect square that goes into 48. So I'm going to rewrite it using 16. Let me get this to disappear. This might take a sec. Yeah. Go away. Oh, that worked, I guess. Okay. So we can rewrite this as the square root of 16 times the square root of 3. Because 48 divided by 3 is 16. Now the nice thing is, we know the square root of 16 is just 4. That's why we wanted a perfect square. So then I can get a whole number out of it. And then I'm going to bring down that rad 3 and smush them together. So I have dealt with the square root of 48. So there's my first piece. Now I have to figure out these individual guys. And I'm going to come over here and do that. The more practice you have with these, the better. And you'll start to like variables. Variables are actually easier to work with, so a little less math involved. Calculation, I should say. Okay. So reminder, there's an implied 2 here. That's why it's a square root. There's a 2 there. First thing you need to do is rewrite this as an exponent. That means the number on your radical is your base. And then your exponent is a fraction. The rule is in over out. So in is 2, out is 2. 2 over 2. And I just did this example a moment ago. That's x to the first, which is just x. So I'm going to bring this down. And again, I'm multiplying all these back together. So this is just x. Let's do the y. Y, exponent, in over out, 4 over 2. 4 over 2 is just 2. So this becomes y squared. One more time for z. Again, write it as an exponent. Z is your base. Exponent is a fraction. rule is in over out. 12 over 2. Twelve over 2 is 6. So this becomes z to the 6th. Now, don't leave your answer like this. This is very messy. What you want to do, your square root should always be at the very end. So all of this stuff needs to come in front with the 4. When you're writing numbers and letters together, numbers go first, letters follow in alphabetical order. So our final answer is 4x y squared z to the 6th, and then at the very end we have our square root of 3. So again, we're just putting everything in that nice order. Number first, letters follow alphabetical order. Anything under the radical is put at the very end. All right, we'll do another one of those. Here we have 3, square root of 300, a to the 5th, b to the 4th, c squared. Again, let's just separate all of that into its individual pieces. 3 is just going to kind of hang out. There's nothing to do here with it. Square root of 300. Square root of a to the 5th. Square root of b to the 4th. Square root of c squared. All right, 3, again, is just kind of there, so I don't have to do anything with it. 300. Sorry, I had to look back at how I wrote it last time. Now, obviously, we don't have numbers that are quite as large as 300 on this chart, but I will tell you, first off, 300 is not a perfect square. I'm going to go through the tedious process of pulling this calculator back up, just to prove it to you if you don't believe me. See, it's ugly. So, you may think, well, I need the bigger numbers to be able to do this. Yes, to follow the rule I showed you, but clearly these end in 2 zeros, so you can divide this by 100. If I divide it by 100, I'm going to get 3, because 3 times 100 is 300. So let me write that down. Square root of 100 times square root of 3. And then 3 is obviously not a perfect square. It's too small for the list. So we're done here with breaking this down. Square root of 100 is 10. Bring down the square root of 3. That part's done. All right. Now let's figure out the variables. So we have the a to the 5th. Again, it's a square root, so there's a 2 there. Write it as an exponent. In over out, 5 over 2. Now, this time, we have an odd number on top. Obviously, we can't divide this by 2. So, let's think about this. I'm going to backtrack a little bit. Now, I don't want to write this exactly the same as the others. It's easier if we kind of just think about the 5 over 2 by itself. So we think of how many times 2 can go into 5. 2 can go into 5 2 times. 2 times 2 is 4. If I go 3 times, I'm at 6. So this will give you 2 remainder 1. If you need more explanation, this is just basic division. You divide 5 by 2. 2 goes into 5 twice. That gives you 4. You're left with 1. So that's where that's come from. I'm going to erase that for space, but feel free to write it down. So what this means, 2 in, 2 out, 1 in. That remainder is left over. We can't take it out, so it has to stay inside the radical. So here's how we'll write this. 2 out. Let me interpret it over here first, sorry. 2 out is a squared. 1 in. It's still under the radical. There's that other 1 inside. So that becomes a squared and then the square root of a. Remember, you can drop this exponent because a to the first is just a. All right, b to the fourth. Again, there's a silent 2 there. Write it as an exponent. B to the 4 over 2. This one, thank God, is much easier. It's just b squared. C squared, last one. Write it in the exponent form. Fraction, in over out, 2 over 2. C to the first, which is just c. All right, I'm going to bring this 3 down here. And then all I have to do is multiply all of this back together. I'm sure this felt pretty overwhelming, especially with that a, how I broke down. The more you work with these, the easier they will get. So now let's multiply all this back together. Remember, numbers go first, then letters in alphabetical order. Square root is at the very back. So first off, my numbers that are not square roots are 3 and 10. 3 times 10 is 30. Letters, we have a squared, b squared, and c. And if you need to, you can always mark these off as you go so you don't forget anything. All right, what we have left? Square root of 3, square root of a. You can multiply these together. They will now be together under that square root. 3 has to come first because it's numbers before letters, so 3a. And that is our final answer. All right. Now we're going to do 3 perfect cubes problems. They work the exact same way as the perfect squares. Okay. So first thing I want to do is break this down. We've got 3 parts here. Cube root of 8. Cube root of a to the 6th. Cube root of b to the 9th. This problem will work out very nicely. Cube root of 8. Notice that I now have my perfect cubes listed above instead of my perfect squares. Again, we did these in yesterday's notes. 8 is a perfect cube. It gives you 2. And then we'll figure out what a and b are. Rewrite it with a fractional exponent. In over out. In is 6, out is 3. 6 over 3 is 2. So that's a squared. B. Cube root of b to the 9th. Rewrite it as an exponent, fraction. In over out, 9 over 3. 9 over 3 is 3, so b cubed. Put it all together. 2a squared b cubed. All right. Hopefully that felt a bit easier. Definitely as much easier than the problem I just did a moment ago. 2 more. All right, we got some things to think about here. This negative is a -1 on the outside. Cube root of -64. Cube root of a to the 11th. Cube root of b to the 16th. Okay, this -1 is just kind of hanging out. Nothing to do with it right now. Cube root of -64. Now, the golden rule of square roots was we couldn't have negatives under the radical. Cube roots, you can have negatives. Let me demonstrate. I'll do a quick example over here and then I'll erase it. If I do, I'm trying to think of a number, 3. If I do -3 squared, it'll give me +9, guaranteed. If I do -3 cubed, that's -3 times -3 times -3. 3 cubed, if you look above, is 20. Is 20. My goodness, I need my laser pointer. There we go. Is 27. And then I've got an odd number of negatives here. I've got 3 of them. So my end number will be negative as well. Another way to think about this, these 2 negatives make a positive here when I multiply, and then multiplying by another negative turns my answer negative. So when you cube, you can absolutely have negative answers. So this is allowed here. I'm going to erase that. You feel free to write it down though. Okay. So the only thing you have to worry about here is make sure you have a negative on your answer. 64 is a perfect cube. It's 4. So this gives you -4. Now I just figure out the letters. This will take a little bit of work. A to the 11th cube root of a to the 11th. Rewrite it as an exponent, fraction. In over out is 11/3. (11/3), if I were to divide that, 3 goes into 11 twice. And then I would have 2 left over because 3 times 2 is 9. 11 minus 9 is 2. Oh, sorry. It goes in 3 times. 3 times 3 is 9, not 3 times 2. I'm getting it mixed up with squared. Sorry. 3 times 3 is 9. 2 left over. So this will be 3, remainder 2. So what this means is I have 3 out and 2 in. So whatever's left over can't come out of the radical. It has to stay. But this is how many I could, goodness, this is how many I can pull out of the radical. So this is how this will look. 3 out is a cubed. 2 in. Remember, this is a cube root. We have a cube root here. And then this is our exponent on a. So it's a squared. And then we would multiply them together. So over here, I'll write a cubed times the cube root. It's a little close for comfort. Let me back it up a little bit. Of a squared. Okay, one more. We have the cube root of b to the 16th. Again, rewrite it as an exponent. B fraction in over out, 16 over 3. If we divide 16 by 3, 3 goes into 16 5 times, because 3 times 5 is 15. 3 times 5 is 15. That's 1 away from 16, so I have a remainder of 1. So this tells me 5 out, 1 in. This is how many can come out of the radical. This is how many have to stay. So we have b to the 5th times cube root of b to the 1st. And then I'll just write that over here. B to the 5th, smush it together. Cube root of just b. Remember, b to the 1st is b. All right, let's put all of this together. Don't forget about this -1 up here. That's why I highlight it. Actually, I'll bring it down. How about that? -1 times that. Okay. Reminder. Numbers go first. Numbers that are not in a radical go first. Then letters that are not in a radical. And then radicals go at the very end. So first, we have -1 times -4. That gives me +4. Next, I do the letters. First letter alphabetically is A. So A cubed. Then I'm going to write b cubed. Sorry, b to the 5th. Okay, now I'm switching to my radicals. That's all I have left. Remember, these can go together under the same radical. I'm going to write them as 1. So I have a cube root. And then go alphabetical. A squared. And then just b. And there's my answer. All right, we've got one more of these. Number 6, -2, cube root of 250, x squared, y to the 9th, z to the 10th. Again, we're going to break it apart. -2 comes out and it just chills for a while. Cube root of 250. Cube root of x squared. Cube root of y to the 9th. Cube root of z to the 10th. Okay. 250. Now, let's go to our calculator. Yeah. There you are. Oh, hold on. This is a cube root, so I have to do it special. Your scientific calculators can do this. There's a button for it. It should look like the button I pressed on here. This one right here, the cube root of n, or the nth root, where you can type in the number yourself. 250 is not a cube root, so we need to find the perfect cube that I can divide by to break it down. So the biggest number on my list is 125. So let's divide 250 by 125 to see if it works. It's 2. And 2 can definitely not be broken down any further. So that's the number I'm looking for. Okay, just got to get rid of this. Go away. Go away. Awesome. Okay. So, this is 125 cube root times the cube root of 2. Cube root of 125 is just 5. And then we can't break down the 2. Not even close. So just bring it down. Cube root of 2. So that's taken care of. Now we just need to do our 3 variables. All right, I'm going to kind of do the work on a case-by-case basis here, just because some of these are nice and some of them are not, and I'm running out of space. So let's rewrite this as a fraction, x to the 2/3. Notice that I can't do any dividing here. 3 does not go into 2. 3 is too big. So actually, I can't do anything here at all. So it stays. Cube root of x squared. Basically, this happens when the inside number is smaller than the outside number. If this is too small, it's definitely not coming out of the radical. So that's something to keep in mind. Okay, fraction. Y to the 9/3. In over out, 9/3. This is very nice. My goodness. 9/3 is 3. Last one. Z to the, 10/3. In over out. Let's break down 10/3. 3 goes into 10 3 times. 3 times 3 is 9. So 3 times 9 is 1 away from 10. So that's remainder 1. So this means 3 out, 1 in. So 3 z's can come out of that radical. So that's z cubed. And then the cube root of z to the first, or just z. So my z is z cubed, cube root of z. It's kind of my scratch work, if you will. Okay. I'll bring down this -2 before I forget. All right, break everything down, put it back together. Don't leave it like this. So start with the things that are not radicals, numbers first. -2 times 5 is -10. And it's okay that this 5 had a radical attached to it. This is just multiplication, so we can move things around however we like. Okay, letters next, alphabetical order. We have Y and Z, so Y is going to go first. Y cubed. Next, I'm going to steal that Z cubed. Yeah. All right, we have cube roots left. So we're going to make these one radical. Again, the order is numbers and then letters in alphabetical order. Our only number is 2. Letters, our first letter, alphabetical, is x squared. And then our last letter is just that z. All right, I've used everything, so this is my answer. All right, that was my last example. That is all for this video. I'm sure some of this feels difficult to pick up. There is a Delta Math to go along with these notes, so hopefully with enough practice, you'll soon get the hang of it. But this is something that you will have to work at and really take your time with. If you have questions, feel free to email me. Otherwise, I will see you guys in class. Bye.